Hey guys, thanks for tuning back in. Today I will try to fix the taco bed on the Sovol SV08. This will adjust the stock bed and don't replace it with an expensive one that you can find online. I'm Andy and this is ATL. Before we start with the video, I just want to explain real quick what the taco bed is. So taco bed is a term from the community, which means that the bed is shaped like a taco. And we don't want the taco bed because we want our first layers to be perfect and stick well to the bed. And in addition to that, I got a few comments on the last videos that the audio is not that good because it only runs on one channel. I try my best in this video to get the audio right and have it in stereo, not mono, so it runs on two channels. And other than that, I want to say thank you because the channel reached 100 subscribers. For a few people this might not seem a lot, but I just think everybody has to start somewhere. Small steps, but consistent ones. So now let's start with the video. This is the Github I found. It's from RAF669 and it's called SV08BedTension. And here everything is stated and very well documented how to do this fix or this modification. So if you need something, just head to the GitHub. It's linked in the video description down below. Here you find all the materials you need, the tools, and as well all the parts for the printer.cfg, as well as the clipper commands we need to adjust our print bed. These are the materials you need. You need 9 of each, except of the 2.5 Allen key washers that are 20mm outer diameter and 4mm inner diameter. These are used to be placed on the plastic bed so we can put our rubber feet on them. The rubber feet have an outer diameter of 16mm and are 12mm high. These will get squeezed down from the bed on the washers that we mount. And to mount everything you need 9 M4 countersunk bolts with a length of 20mm. Sorry guys, somehow I was a little bit in a rush and forgot half of the tools you need. You also need CA glue, a Phillips head screwdriver, a size 3 Allen key, a cutting knife or best case a hole punch, and a prying tool, something to get the magnetic bed and the aluminum bed out of the plastic casing. To find the bolt holes easier on the magnetic bed, there is a 3D print model. I would highly recommend to print this if you're doing this mod. Now let's head to the printer. I flipped the printer on its side and the first step here is to disconnect the heating bed from the power board. I have a cooling fan for this Mosfet board here, so I need to remove this too. If you're interested in printing one of these brackets for yourself, check my printables page, there is the STL to download. Once we can get to the connectors, we need to disconnect 1, 2, 4 and 1 for the ground. The grounding wire is additionally connected here to the frame. Here you need the Allen key. The ground on the frame is with a ring connector, so you need to get the bolt out. After that, put it back in so we won't lose it. As you can see, here is a thin cable that comes from the heating bed. This is the thermistor and we need to unplug this one from the motherboard and also get it out of this cable channel here. I already removed the PEI sheet and placed the 3D printed parts on the bed. As you can see, you need to align them with the 3 bolts on each side, and after that we can cut into the magnetic sheet so we can get to the bolts on which the bed is attached. I got the first hole free. It's a little bit messier or bigger than I thought, but yeah, we should get the bolt out there with no problem. It's a little bit fiddly, but it's surely doable. I got all the bolts free. It was tedious work, so if you are trying to do this mod, get yourself a hole punch in the right size, that would be much easier. And here in the middle, Sovol didn't even bother to put the bolt in. So out of the box there are only 8 bolts that hold the bed down. Now we can start to unscrew all the bolts so we can get the bed out. All the bolts out, and now we try to pry the heat bed out of this plastic casing here. I got some prying tools. I used them to work on my car, and let's see if we can get it out with them. The bed is out, and as you can see, the magnetic sheet is wider than the actual aluminum plate, and what I recommend is use such a prying tool and move around the outside so you can get the magnetic bed off the aluminum plate, and after that you can easily just lift it out. And here are the wires we disconnected before. Next step is to trim this axis of the magnetic bed. For the next step we need our washers and the bolts which attach the bed, and now we will put a little bit of CA glue here on the plastic part. Make sure you don't get any CA glue into the bolt threads. Then we put the washer on, and to let it all dry we secure it with the bolts as mentioned before, and when they're all dry we can put the bolts back out. All the washers are in place. I already took out the screws, and now we will put the rubber spacers on each spot. All rubber spacers are in place, as you can see, all 9 points. And now we will begin to reassemble the bed. So first we put all the wires through here, and then we place the bed on all the rubber spacers, and then we use the 20mm countersunk M4 bolts to fix the bed. Only tighten them lightly. This has been easier than thought, and now, as you can hear, we need to tighten them down, or kinda the same strength, so try your best, and it is recommended to tighten them in a cross pattern. When the screws are tightened down, all with kind of the same strength, you want to tighten them even further so that the rubber spacers kind of squash a little. So right now all are even, and let's say you want to put 4 full turns on every screw so everyone gets an even squish. Once you've done that, put the PEI sheet back on, flip the printer over, reconnect all the wires from the bed to the Mosfet, and after that we can start to measure and calibrate the bed and adjust it so it is perfect and we don't have the taco bed anymore. Since the bed is now higher, the nozzle scrubber is too deep and we can't reach it. For that you can either print a spacer, so this one gets higher up, or as I will do now, I just remove it because I don't use this pin here to get the C offset, and I reprinted a part. Just says scrub me. Here we'll put a new brush and just use this to do my nozzle cleaning. In the future I will remove these 2 cables. This one here is from the filament sensor, which I don't use because I have directly one on the extruder, and the cable we unplugged right now, so it is a little bit tidier back here. Alright, looks good. Maybe needs to be a millimeter higher, but should definitely work to get my nozzle clean, so I can do a correct and perfect C offset. Maybe I will just modify this and print it a little bit higher. Next step is to level the gantry, and after that we will adjust the bed according to the gantry. For that I printed 4 of these spacers. One is 75 millimeters long, and I will put one on each corner and lower the gantry on the spacers. For this part, make sure that the printer is powered off, otherwise the motors are engaged and you won't be able to push the gantry down. The gantry rests on the spacers, and now we can remove them and power on the printer. You will need the spacers later on, because now we will power on the printer and individually power each Z motor, so we get the gantry perfectly level. With the commands you see on screen, you can adjust each motor individually. So when you do that, grab one of the spacers and always check if everything's the same distance. I aim to have a little bit of a resistance when I slide the spacer here on each corner, and after that we can continue. I also drew this quick drawing of the motors, so you have easier time to understand where which motor is and which command you need. Once the gantry is level, you can heat it up. Now it depends on what you're mostly printing. When you print PLA, heat the bed to 60 degrees, and if you print ABS, heat it to 95 or 100 and let it heat soak for 15 to 20 minutes. If your printer times out after 10 minutes and you want to heat soak the bed for 15 to 20 minutes, you just need to adapt this code in the printer.cfg, as you can see here on screen. So my printer will idle timeout after 20 minutes. In the GitHub there are two things you need to insert into your printer.cfg. This is the bed screws and the screw tilt adjust. Note that these coordinates here are for the stock Sovol SV08 with the inductive probe. So if you have a different toolhead, you need to adjust these X and Y coordinates. In my case I use a dragon burner with a big 3-tech eddy, and the probe is mounted on X0 and Y30 of the nozzle. So I modified the coordinates to fit my printhead and my probe. So grab the code with this icon here, you can copy it to your clipboard, switch to your clipper, add to machine, and go into your printer.cfg. It doesn't matter where you put it, I put it right here, and these are my adapted coordinates, as you can see. I ran the screw tilt adjust command. After that the printer probes all the screw points, and you get this window here in Clipper, and you have to note that the middle screw is the base, so every measurement and calculations are depending on the middle. So if you want the bed to be squished further down, you have to tighten the center screw before you start with the screw tilt adjust command. As you can see here, we get the values 0.29, 0.08 and so forth. This means 0.29, this is half a turn of the screw, because 1, as we can see on the back right, 1.03 means a full turn. This is like a clock, so 0.45 will be 3/4 of a turn. So after that I will note these values down, lift my printhead up with the clipper commands so I can remove my PI sheet, and after that I will try my best to turn the screws the right amount as listed here on this window. These are my new values. As you can see, they are a lot better. So I will note these values down, adjust the screws accordingly, and then we do a screw tilt adjust. I'm on my third try adjusting all the screws, and I made a mistake. As you can see, here are arrows, so make sure of the arrows. So you spin the bolt either clockwise, as you can see here, or counterclockwise, as you can see here. I will now pay attention on the arrows here and adjust the bed. this is my final adjustment. As you can see, the values are all very low. We want them to be between 0.00 and 0.05. So everything here is in range except of the mid left. I will just give this one slight turn. Now that all the values are on or below 0.05, you want to do quad gantry leveling. And after that, we can do the bed mesh and compare it to before. I ran the bed mesh, and this one here is the one prior to the adjustments. My bed was not that bad. You can see it's a deviation of 0.2 millimeters, which is not a lot, but if you think about it, this is already a layer height when you print with 0.2. And this is the new one after the adjustment. I also did a mesh that is high resolution, so it's 30 by 30 points. And here you can see it's a range from 0.13, which is okay for me, because the Eddy will scan the bed before every print and adjust the C height accordingly. Now we're done with the modification. As you saw, the bed is flatter than before. I would definitely recommend this modification if your bed is in worse condition than mine. If you like what you see, consider subscribing and liking the video. This helps the channel out, and maybe I can get some sponsors so I can do more projects like this or even crazier ones. The next video will probably be about dampening or isolating the enclosure of the printer, so I can get higher print room temperatures for printing ABS. Thanks for watching. Bye guys.